review, right? Let's break this down to its simplest terms. What does linear mean? Straight line. Right, give me a thumbs up if you remember that. Linear means straight line. Okay.
Nonlinear means not straight.
Do you remember that, Johnny? Okay. So if linear means a straight line, what do you think nonlinear means?
Not a straight line.
Not a straight line. Not necessary. So, when an equation has an exponent in it, this is what we talked about last week when we were describing functions. We know it is a nonlinear function. If the exponent is a 2, which is what we're going to be seeing a lot of today, the shape of the graph is a parabola. Everybody say parabola. Parabola.
Parabola.
Right? Either one, I don't really care. It's technically it's a parabola, but I don't know why that people have a hard time saying that. Parabola is the name of the function, right? It looks like a little U. You guys okay?
Yeah.
Doesn't sound okay. All right. So here's our table. We got a lot of inputs because I want to see a lot of points here to get my graph nice and accurate. And the function that I'm going to be using is y equals x squared. Okay, is that a linear function or a nonlinear function? Nonlinear. How can we tell just by looking at the function? Because it has an exponent. Do you see a b value there?
No.
So this must be proportional, right? No, why not? That's right. Hiba remembers, if it's nonlinear, it's automatically non-proportional. What's up?
I need a student last name Meckling or Maya Meckling or something like that.
Mariah Meckling? All right, like we said, you can't be nonlinear proportional because part of being proportional is being a straight line, right? So we got to be careful with these exponents. A lot of people like to just plug a number in and multiply it by that little 2. That is not what we're doing. That exponent tells me I'm multiplying x by itself 2 times. So if my first input is negative 3, and I plug that in for x, it becomes negative 3 squared, which is negative 3 times negative 3. Right? What's a negative times a negative? Positive. And what's 3 times 3? 9. So my input is negative 3. That gives me an output of positive 9. Everybody with me so far on that? We remember how exponents work, hopefully? Yeah? Okay. If I take my next input, negative 2, my equation becomes y equals negative 2 squared. If I was going to expand out negative 2 squared, what would that look like? Something times something. Negative 2 times negative 2. Not negative 2 times 2. Negative 2 times itself. Well, what is negative 2 times negative 2? Positive 4. So this solution here is negative 2 comma positive 4. What about if I plug in negative 1? Y is equal to... Yeah, you got it. What was it, Ray? Negative 1 times negative 1. Well, what's negative 1 times negative 1?
Positive 1.
Positive 1, right? We got to think a little bit more about this. All right. And if I plug in 0, nice and simple, 0 squared. If I were to expand that out, it would be 0 times 0. Well, what's 0 times 0? 0. So again, just because this function goes through the origin, that doesn't mean it's proportional. It has to be a straight line through the origin to be proportional. Now we're going to see something interesting happen. Let's plug in positive 1. Am I going too fast, by the way? Okay. Loud and clear. If I plug in 1, I expand that out, I get 1 times 1. Well, what's 1 times 1? 1. If I plug in 2, My function is y is equal to 2 squared. Well, 2 squared is just 2 times 2. And what's 2 times 2? 4. So I get 2 comma 4. And if I plug in positive 3, I get y is equal to 3 squared, which is 3 times 3 when I expand that out. And what's 3 times 3? 9. One sec. Go ahead. Notice anything interesting about our outputs here? Anything that stands out? It's a pattern. What type of pattern does it look like, Rhea?
It's like it's repeating, but not really. It's like 9, 4, 1, then the zeros in the middle, then it's like 1, 4, 9.
Exactly. It's like a symmetrical pattern. Like remember we talked about reflections, like the little poster up there with the water. It's reflected. So my outputs up here get reflected down to my outputs down here with my 0 right there in the middle. Okay? Now again, we see, hey, I've got multiple 4s. Is it okay for me to have repeating outputs? Yeah. What can I not have repeating? Inputs. Are there any repeating inputs? No. So this would still be a function. Now we're going to take all these points and plot them. We'll start here, negative 3 comma 9. Okay, on my graph, I'm going to start at the origin. Negative 3 is my x. There's my x. So I'm going to go to negative 3. And I'm going to go all the way up to positive 9. Make my first point. What's my second point that I'm going to plot?
Negative 2,
Comma.
4.
Perfect. I go over to negative 2. I go up to 4. Boom, there's my second point. What's my third point I'm going to plot? It's the orange one, I think.
0, 0, comma 0, negative. Oh wait, negative 1.
We'll get to the 0, 0. Yeah, negative 1 comma 1. Negative 1, 1. Then we're going to plot, you said what, Ray? 0, comma 0, right there at the origin. Now let's just pause there for a second. Do those 4 points make a straight line?
If you know what?
It kind of does, right? But look. No,
Oh,
no, no.
it's not proportional.
Yeah. The fact that it's not a straight line means it's nonlinear. Yeah. But what's going to happen now? What point am I going to plot after that 0, 0? 1, 1. I'm going to go over 1, positive, and I'm going to go up 1, positive. What am I going to plot next?
2, comma 4.
2, comma 4. At the origin, I'm going to go over 2. I'm going to go all the way up to 4. Make my next dot. You guys starting to see what's happening? What's my last point? 3, 9. I'm going to go over to 3. I'm going to go all the way up to 9. I'm going to make my last point. So we just plotted 7 points. Do those 7 points form a straight line? No. So we're still going to connect the dots, but we're going to get an interesting result. Okay?
That one thing on the bottom.
That's right. We want to make this as round as possible, so just starting up on the left, we're going to make our nice little U rounded out on the bottom. Don't just make like a super sharp V. It's got to be nice and round just like that. What do we call this shape again? Someone say a graph?
Parabola.
Parabola or parabola. That's right. Parabola. I'm going to come around and take a look at how all your parabolas are looking. Oh. Nice. Whoa.
You even have nothing on your paper.
Why is it matter what I'm doing? I'm doodling. I'm doodling.
What is that? It's gotta be accurate. Because on a test, that'll get you 0 points, my friend.
Doodling, that's what it's called.
I bet you. It's not like that. No, like it's actually like.
We can talk about that a little later if we have time. All right. Quick show thumbs. How we feeling about that? Thumbs up seems pretty easy. Seems doable, not too crazy. Thumbs sideways, kind of a little bit weird. Okay. We got a lot of good practice with these function tables, so now we just have to make sure we're doing the exponent right. If we're not doing the exponent right, we're getting the wrong outputs. We're not going to get a nice little pretty U-shaped graph like we had here. All right? So let's try it out. Let's see what we can figure out with these next couple ones. This is good practice because these are different. A lot of times you feel like you got it and we're talking about it all together.
What is these fives doing?
And when it's just you and your brain, it starts to fade.
I don't have any book no more. So I got rid of it. Who killed it? Me. Who killed it? Have you seen my notebook?
Sure
Take a few minutes, give these a try. See if you can work through them on your own. If you're having trouble or want to make sure you're doing something right, please let me know before you get too deep in it. But I see a lot of you guys are off and running already, so go ahead and give it a shot. Again, we should see nice symmetric outputs, right? Where the two numbers up here flip down to the two numbers down there. That zero number is different in the middle. If you don't end up with a pattern in your outputs, don't graph it, obviously, because something wrong. Make sure it's x squared plus 1, so always going to go up 1.
Yeah, you got that wrong. How did you put that wrong? That's a lot.
Yeah.
All the answers are the same. I mean, I got the
Or I could get
Well, you don't do the graphing until you do the table.
Oh, no, I don't
So try to do it on the other page.
I don't want your bonus.
This is what I see back for.
every time we square a negative number, we end up with a positive number, right? Because a negative times a negative is going to be a positive. Positive 4, positive 1. Because then it'll be 5, 3, 1, 3, 5. That nice symmetrical, like we had here. It's those first two. When we square that negative number, they become positive. How many of those look great? Make sure you got little arrows on the end. So when we square a number, it becomes positive, right? So negative 2 squared is 2 times 2 is 4, plus 1, which is what? No, because what's a negative times a negative? And then plus 1 gives me. Do the same thing for that second hand. Those look great. Yeah, it should be shaped like a U, right? So, on this first one, negative 2 squared. What's negative 2 times negative 2? Negative 2 times negative 2? Well, what's a negative times negative 2? Oh, so it's positive. Plus 1 gives me. Yeah, and you square a negative one time the positive every single time. So anytime you have one of these negative numbers and you square, it's going to end up being positive, right? If I have 2 and negative 2, those should have the same outcome. 1 and negative 1, those should have the same outcome. But that middle one should be different. That's how we end up getting that one U shape. So for all of these, that should be how it is. It's like symmetrical. No, you're pressing the wrong button. I'll show you which button to press. Okay, I gotta get you this whole unit.
We're supposed to press this.
For what? Oh, okay. So we're plugging in negative 2, right? The negative on this one down here. Negative 2 squared is 4. Oh, okay. Okay. If we do negative 2 times negative 2, we get 4, right? The reason why I'm doing negative 4 is because they want you to put the negative in parentheses, like that. If you don't put it in parentheses, technically it's negative, and then 2 squared. The 2 squared is 4, times negative is negative. So I would say the best thing to do is just negative 1 times boom.
Can you explain these for me?
It's just,
you know the thing you give us the number? So X and Y is negative 2. Can I go to the bathroom?
Sure. How's it going on
So
there?
basically just the same thing.
Okay.
It's the same thing, just one.
Okay. Yep. All right. Let's take a look-see here so we can make sure we're all on the same page before we get our worksheet. Worksheet is not bad. It's only like 3 problems, so it shouldn't be too bad.
3 problems?
Yeah.
That's great.
All right.
I love math.
So this is where I knew we were going to have some issues, right? If I plug in a negative number and square it, it's always going to give me a what? Positive. A negative 2 times a negative 2 is a positive 4. Plus 1 gives me 5. A negative 1 times a negative 1 gives me a positive 1. Plus 1, that gives me 2. Right? So the one we started with was just literally x squared. We're just squaring the input. Now we're going to be adding and subtracting little things on and off to it, right? If I plug in 0, obviously 0 squared is just 0, plus 1, that gives me 1. Now when I plug in positive 1, what's a positive times a positive? A positive, duh. So 1 times 1 gives me 1, plus 1, that gives me 2. And when I plug in positive 2, again, 2 times 2 gives me 4, plus 1, that gives me 5. What do we notice about the outputs?
It's doing the reflection.
It's doing the reflection, right? It's symmetrical across my origin. So yeah, the origin output is going to be different because there's no negative 0 I could plug in. But a negative 2 gives me the same output as a positive 2. A negative 1 gives me the same output as a positive 1. If you don't see this pattern here, and there's an exponent, something went wrong every single time. So if I were to plot these points negative 2, comma 5, I'm going to go left 2, up 5. Negative 1, comma 2, I'm going to go left 1, up 2. 0, 1, I'm just going to go up 1. 1, 2, 2, 5. There's my little U shape. I'm going to connect them up, go all the way through my points, and put arrows on the end. You got to make sure you're putting arrows on the end. I'm tired of writing draw your arrows on your tests. All right? You wrote a sentence in English class and forgot to put a period, teacher would say the same thing. So make sure you're putting your little arrows on the end of your parabolas. Give me a thumbs up if your parabola looks like that. Sounds like a disease?
Yes. Parabola.
Go, see? I told you.
You're thinking of Ebola, probably? Parabola? Yeah, I know. Well, further away. We'll talk about it later. We're not going to talk about it right now. Okay. All right, next one. X squared minus 2. Negative 2 squared. What's negative 2 squared? Is that negative 4?
That's positive 2.
Positive 2? Negative 2 squared? Positive 4. That's right. Minus 2, that gives me 2. All right, if I do negative 1 squared, what's negative 1 times negative 1? 1. And what's 1 minus 2? Negative 1. If I plug in 0, what's 0 squared? And what's 0 minus 2? Negative 2. I should see that reflection, right? If I plug in 1, I get negative 1 again. If I plug in 2, I get positive 2 again. Right? Again, that's symmetrical pattern. Negative 2, positive 2 is right there. Negative 1 is right there. 0, negative 2. 1, negative 1. And 2, positive 2. And there's my second parabola on number 2. Give me a thumbs up if those are the outputs that you got there on number 2. Anybody get that on their own? Sophie, Jawad, Gianni, Angelina, Jasmine, Araya, Caleb, Anai, Emily, Daniel. Good. Julian. Nice. Alyssa, Ian. Great. Last but not least, number 3, x squared minus 4. If I plug in negative 2, what's negative 2 squared? 4. Well, what's 4 minus 4? 0. If I plug in negative 1, what's negative 1 squared? What's 1 minus 4? Negative 3. We're almost done. If you get it, that's great, but there might be someone near you who doesn't get it, so just hang tight while we finish this up. If I plug in 0, what's 0 squared? 0. And what's 0 minus 4? Negative 4. And I'm going to start to see that reflection again. 1 minus 4 is negative 3. And 4 minus 4 gives me 0. There's negative 2, 0. Negative 1, negative 3. 0, negative 4, 1, negative 3. And 2, 0. Obviously, you want to go through all the points unlike I just did right there. That's what we get. Any questions I can answer about that? Good show thumbs. How are we feeling? Thumbs up. Seems easy. I could do that. I did do that. Okay. Good. Lots of thumbs up.